We are told that radio waves and microwaves can control objects at a distance by transmitting through the air. What manner of dark physics is it that can achieve such results? Using a drone, we'll break through to the gritty mechanics of what's going on. We'll consider topics such as AC current, waves, electromagnetic induction, and even a smidgen of resonance. This will help you master this fascinating, hidden away area of the syllabus. Right now, the air where you're watching this isn't empty. It's full of an invisible, chaotic soup of electromagnetic radiation. Wi-Fi routers, 5G towers, your neighbour's microwave, the emergency services are all pumping out electromagnetic radiation. Every one of these waves is crashing into your drone's antenna. So how come, when it's flying, your drone doesn't get seriously confused and just drop out of the sky? The answer comes down to a beautifully timed, simple conversation between two pieces of metal. It starts inside the transmitter of the controller as an alternating current. Don't just think of this current as a steady flow of charge. Rather, it's an alternating current in which the electrons are forced to accelerate up and down billions of times a second inside the wire of the antenna. And here's a fundamental law of physics. Whenever you accelerate a charged particle, it causes a ripple in the electromagnetic field. Because these electrons in the wire are vibrating at a specific frequency, say 2.4 gigahertz, they launch an electromagnetic wave that ripples off out into the environment at the speed of light. This is the same frequency that your microwaves use to heat pizza or your phone to stream a video. Let me know in the comments below why you think your microwave, if it's on, doesn't cause your drone to crash. Now, these waves travel up through the chaotic 5G Wi-Fi filled soup until they reach the antenna of the receiver in your drone. When an electromagnetic wave passes into a conductor, it causes the electrons to vibrate. This in turn induces a current in the antenna of the receiver, which, you guessed, is exactly the same frequency as the current in the transmitter. But wait, don't the other Wi-Fi, 5G, etc. signals in the air cause induced currents in this receiver antenna as well? Yeah, they do. It's a chaotic mess here too. And this is where the magic happens. Inside the receiver is what's known as a tuner. Think of this a bit like a swing. If you push a kiddie on a swing randomly, they're only going to swing a little bit. But if you push at exactly the right time, then the little kiddie is going to build up a big swing. This is known as resonance. The tuner inside the drone acts in a very similar way and is therefore able to effectively ignore all the signals that it's not tuned for and just listen out for the one that it is tuned for. So next time you fly your drone, don't think you're just playing with a toy. You are actually orchestrating a beautiful symmetrical dance between the electrons vibrating in your hands and the electrons vibrating in the receiver, without any physical connection. And you've got to admit this is pretty cool. Geography ain't got nothing on this. So don't fall for the trap of just saying radio waves connect them. Rather, try and use words like induction, vibration, and even resonance. Now that you've got the logic down for a drone, you can apply the same surgical method to an actual exam question. If you think you would benefit from a precise no-fluff approach to answering a 6-mark question on specific heat capacity, then check out this next video.